Hi, today we're going to be talking about Venn diagrams regions. So there are many times where we only want to know the number of elements that are in the universal set versus what the specific elements are. So anytime this is the case, we do not need to know or show each individual element on the diagram. So instead, we just write the number of elements in each section and we place them inside of parentheses. So, example number 1, it says use the Venn diagram to determine which statement is true or false. So remember, anytime you have a Venn diagram and there are numbers written inside of parentheses, that is the number of elements in each section. So, question A says that the number of elements in A is equal to 7. So if I circle all of the numbers that are currently in A, I should get 7. So I have that there are 7 elements that are only in A, and then there are 4 elements that are in A and B. So that is a total of 11. So here I would be able to say that the number of elements in A is equal to 11, which means that that is a false statement. All right. Question B. It says that the number of elements that are not in B are 10. Well, if I circle all of the numbers that are not inside of the circle B, I would get 7 and 3. And I know that 7 plus 3 is 10, which makes this true. All right. Next, we have question C, which asks, and is stating that the number of elements in the union of A and B is 17. So remember, union means I don't care whether you're in A or B or both, you're basically merged together. So the number of elements that are in A or B, remember, that union symbol, the key word for it is or. If we add all of those numbers up, we have 7 plus 4, which is 11, plus 6 is 17. So this is a true statement. In question D, it says that the number of elements in A but not B is 11. So I need to circle all of the elements or the number of elements that are in A, but they cannot be in B. So as you can see here, I have 7 elements that are in A that are also not in B or inside of the circle B. So that is false. So I'm going to say that the number of elements that are in A but not B is actually equal to 7. And we know that this statement that it was 11 is false. All right. If we look at E, it says that the number of elements that are in the intersection of not A and B. So the number of elements that are not in A are going to be 6 and 3. And then the number of elements that are in B are going to be 4 and 6. So when I say I want to find the number of elements that are in the intersection of where they cross, I get 6, and that is true because 6 is the only one that has both of them around it. So that is a true statement. All right. So last one, F, it says I want to find the number of elements that are neither in A nor B. So if I want to find the number of elements that are in neither A nor B, then I don't want them to be in either of the circles, which means that I would have that is 3. So I'm going to put that the number of elements in neither A nor B is equal to 3. So that original statement was false. All right. So let's look at example number 2. Example number 2 says, given the universal set or the number of the elements in the universal set is 32, and that the number of elements that are in P is 18, and the number of elements that are in Q is 13, and the number of elements that are in P and Q is 7, we need to find the following. So the first thing that I'm going to do here is I'm going to write this in the form of a Venn diagram so it's easier for me to capture what is going on. So I draw my universal set, and then I'm going to have my 2 circles. Okay, so we have set P and set Q, and we know that the rectangle is already set U. So it's telling us that the total number of elements is 32 in all. P has a total number of elements of 18 between P only and the intersection. And then the number of elements that are in Q is 13 between the intersection and the number of elements that are in Q only. The number of elements in my intersection is 7. So I'm going to start there first so that I don't count things twice. So if I go back and it says the number of elements that are in Q is 13, well, if I already have 7 of them in the intersection, that leaves me with 6 that are in Q only. All right. And remember, we can represent these inside of parentheses so that you won't be confused. So I will have 7 here and 6 here inside of parentheses. If the set P has 18 elements in it, and I already have 7 of them in the intersection, then that leaves me with 11 elements that are not in the intersection but are also in P. So if we add up 7, 11, and 6, that will give us 24. And if we have 32 elements total, then 32 minus 24 leaves us with 8 elements that are not in either of those, but they are in the inside of the universal set. So let's answer these questions. So question A says we want to find the number of elements that are in the union of P and Q. So remember, union means either or, you don't care which one. So if I want to find the number of elements in P and Q, I can just add up 11 plus 7 plus 6, and that will end up giving me 11 plus 7 is 18, and 18 plus 6 is equal to 24. All right. If I want to find the number of elements that are between the intersection of P and not Q, then I know that the number of elements that are in P is going to be 11 and 7. And then if I say the number of elements that are not in Q, that will end up being 11 and 8. And if I want to find out where those intersect or if they cross, I'm going to choose the 11 because it has both colors around them. So my answer here would be 11. All right. If I look at C, I want to find the number of elements that are in Q but not in P. So the number of elements that are in Q and not P, this is going to be 6. Because I have 6 elements in Q that are also not in P. All right. So if you have any questions on Venn diagram regions, please let me know and I will be more than happy to assist you. Have a great day.